In this video, what I'm going to do is I'm going to talk about the distinction between simple and compound statements. I'm going to talk about logical connectives and their formalization, and a little bit about dyadic formalization.
All right, the first thing that I want to do here is discuss the notion of simple versus compound statements. So this is the first distinction that we run into when we're dealing with formal logic. So we haven't really gotten to the formalization yet, so that's what we'll be doing here. So we talked about what statements are. A statement is anything that can be either true or false. It has truth value, so things like commands are not statements, questions are not statements, proposals are not statements, and also gibberish are not statements, because they are things that we can utter or write down that are neither true nor false. So what would be an example of something that would be a simple statement? Well, let's talk about the notion of a statement. So when we're talking about the structure of a statement, and this is true regardless of language, but we'll take a look at English here. You say something like, today is Wednesday. All right, so let's say that's the case. And this is a statement because I'm going to just label it S1 for the sake of having this here. So today is Wednesday. This is a simple statement, but first let's get to why it's a statement. It's got a subject. So right here, this is the subject of the sentence, and now that it's about. It's got a verb right here, and then here it's got a predicate. So what does that mean here? What the sentence is about? The verb, what it's doing today is. And I could stop there, but the predicate here adds back to the noun. It tells me more about the subject of the sentence. So today is Wednesday. Now, every statement will at least have that. So just something by itself. Like if I just say the word no, that is not really a statement with any kind of truth value to it or anything like that. So what that means is a statement is something where it has one truth referent. So something like this. Here's what I would do with this, and what I want you to be able to do on quiz 2 is, this is a statement. What I want you to be able to do is to represent it formally. And what I mean by that is here, we're going to basically shrink this down into something that stands for this. So what I'm going to do is I'm going to arbitrarily underline a word. There are 3, and I'm just going to pick one. Okay. I chose to do the W there. I could have done the today or the is. And what we're going to do is we're going to say, here's how we can represent this statement formally. We're going to take the first letter of the underlined word, and that's going to stand for the entire statement. So if I say today is Wednesday, the first letter of the underlined word is W here. So I'm going to write here, how do I represent this formally? So here's the statement. What's going to be the formula for it? And I'm just labeling these here. We're going to say, you can represent this by just saying W. So what does W stand for? It stands for today is Wednesday. Why? Because I said so. I could have chosen a different letter. I could have underlined today, and we would have chosen T. So it doesn't, and this W doesn't stand for the word Wednesday. It stands for the statement today is Wednesday, which is a little bit different. So this is a simple statement because there's only one element here. As soon as we start bringing in other elements, it's no longer a simple statement. It ends up being compound. So compound statements are where we have bundles of simple statements. So let's look at an example of that. So we've got this still. Today is Wednesday. Now look what I'm going to add a little bit to it. Today is Wednesday, and tomorrow is Thursday. Okay, so this is an example now of a compound statement, and it's compound because it's got this thing going on right here. This is a connective. This is something joining two statements together. So this thing going on right here, today is Wednesday, it's its own thing. It's got its own subject, verb, predicate. Subject there, today, verb is, predicate Wednesday. But what I'm going to do is that part's going to stay the same. I'm just going to say, all right, so W is still going to stand for today is Wednesday. But then we have this, and what this is a connective. So I'm going to have W and whatever that means, then whatever this is. Now this is tomorrow is Thursday. This is its own separate statement. I could have this by itself. So I'm just going to arbitrarily underline Thursday here. So the statement tomorrow is Thursday is going to be represented by just the letter T, because that's the first letter in the underlined word that I've selected. So this statement here can be represented by the formula W and T. Now there's actually a formula for what this should look like. Okay, so when we get into formal logic, the symbol for and that I'm going to use is a dot like this. So what is the dot means and vice versa. So the way I could represent this whole thing as a formula is this. W dot T. So this is our fully functioning formula there. I'll call it that. So what is W dot T? What does it mean? Today's Wednesday and tomorrow is Thursday. Now I could also just have this by itself if I wanted to. What would that mean? In this context, today is Wednesday. What would this mean in this context? Just by itself? Tomorrow is Thursday. But what I wrote here, and notice there's a period on the end, so I keep formalizing until I get there. And that means that's a stop. When you get to the period at the end, that means you can stop. But so this says today is Wednesday and tomorrow is Thursday with the variables that I've been given. So this means, again, a statement like just W by itself. Like if I had just this W by itself, okay, that would be a simple statement. If I had just this T by itself, that's a simple statement. As soon as we have like a symbol, not a letter like this variable here representing a statement, but a symbol that does something to fuse two or more together. And there's one exception where something is just modified. We'll talk about those. So any kind of modifier that goes where it goes from being just a simple one little statement by itself, or formally one little letter by itself, anything that modifies that makes it into a compound statement. So what I'm going to do now here in a moment is we're going to get into the different ways which you can connect statements together. So there are a couple of different species of that. Let's get into that. So the first kind of connective. So what I'm going to do is here, I'm going to go through the different kinds of connectives. So we already mentioned one. The first kind of connection there is the notion of a conjunction. So what's a conjunction? That's where we see the word and. So a conjunction is where we see the word and that's a way that something can be joined together. And the symbol that I'm going to use for that is going to be the dot. It's going to be a dot like that. And so this dot means and the and means dot. And so that's why I can say something like we did a moment ago. Today is Wednesday and tomorrow is Thursday. Now there's also some synonyms for and, other words that mean and I'll get to that later. For now, I just want you to know this is one of the connectives, the notion of a conjunction. That's where you got an and basically the dot connects things together with the word and. So even if I don't know what this variable stands for, if I say something like A dot B, what that means is A and B, whatever A and B stand for. All right, so that's one notion, the notion of and as a conjunction and as a connective. Well, what are some others? Well, another one that we're going to go over is the conditional. And this is where we have statements where most of the time the way we're going to do it is we're going to say if-then statements. Okay, and those are going to be represented by me with an arrow always pointing towards the right. There are some logicians that have arrows that point to the left. I don't like doing those. There are some people where instead of this arrow they use this horseshoe symbol. I hate this because I can't remember if it's a bullet where it's going that way or if it's supposed to be like a magnet that's pointing that way. So I find it infuriating, so I don't use that symbol. But if you look this stuff up online, you'll probably see that symbol quite a bit. But I much prefer the arrow. And so the way that the arrow works is it means if-then statement. So just like A dot B would mean A and B, A arrow B, whatever on the left side follows the if, and whatever's on the right side follows the then. So that would mean that this thing that I just wrote here means if A, then B. There are some other ways of saying if then as well, other ways of saying the arrow. I'll get to those later because they end up there's one expression that ends up being really frustrating until we get through this a bit. There's other ways that we can talk about this as well, but this is the basic way that I want to go over here. So we've got the conjunction, we've got the conditional. Then we've got the biconditional. And these ones, I'll say, in our everyday speech are rarer. I guarantee you remember this one from any math class that you had. It's this expression, if and only if. Okay, and sometimes you might remember from like geometry, it might get reduced down to IFF. We'll just say this is a rare case. Well, in logic it's not as rare, but like in everyday life we don't use if and only if expressions very often. It looks like it's kind of combining these two things together. In a way it kind of is, but for now we'll just say that the symbol that's going to be there for it that I'm going to use is a double arrow. It looks like an arrow pointing in both directions. Okay, some people will use this like triple equal sign for it. That's fine too. And so when I say something like this, a double arrow B, then I'm saying there A if and only if B. Now what that means here, and I'll talk more about this later when we get to looking at biconditional specifically, is that means A is the same thing as B and B is the same thing as A, really. So that's like a biconditional, something like an object, a three-dimensional figure is a triangle if and only if it has three angles. Okay, so that means, well, if it's a triangle, then it's got three angles, and if it's got three angles, then it's a triangle. That's all that means. If and only if just means whatever it is you're talking about as a definition, it works both ways. Or if I say something like, all let's say all bugs are insects, that works. Are all insects bugs? That doesn't work, so that's not an if and only if statement. Okay, it doesn't work both ways. Or all squares have four sides, that works. But if I say all four-sided shapes are squares, there's diamonds, there's rectangles, there's rhombuses, that doesn't work. So those are examples of not if and only if statements. A statement is an if and only if statement if it works in both directions, and it's a definition. So that's the notion of a biconditional. These are connectives as well. So we can also have disjunctions. Now, what are these? These are or statements. Okay? Now, there's two kinds of or statements. There's just plain, what I'll sometimes call vanilla or. So there's the inclusive or, which I'm going to represent. This is called the wedge. It looks like the letter V. Okay, this is an inclusive or. So something, it's going to look like this. This is A or B. But when it says it's inclusive, what that means is maybe both. Okay, so something like you can get the soup or you can get the salad. Well, I'd like to get both, please. You can do that. Okay, that's an inclusive disjunction. You get one or the other. Well, I want to get both. Okay, that's not impossible. That's fine. Okay, there's also the exclusive disjunction, or the XOR. So the symbol for that, I call it the sniper sight, and so we can have this. And sometimes even for short, people will say A, just slightly more clearly. People will say A XOR B. All right, to make it distinct from the inclusive, people will say A XOR B. And the XOR, it's almost like we're saying XOR. Sounds like a radical fantasy villain. So XOR. And so this means it's one or the other, but it can't be both. That's what we mean by an exclusive disjunction. Okay, so A or B, but it can't be both. You have to pick one. This one is one or the other. Maybe you could get both if you want to. Okay, this one is one or the other. You have to pick one. If you have one, basically, if there's one, there's not the other. That's the way it works. That's why it's exclusive. Pick one. Okay, so for example, an example of an exclusive disjunction. Let's say this was a Monday, Wednesday class that we're meeting in person, and you wake up in class and you don't remember what day it is. Well, we know this. It's Monday or Wednesday, but there's no way that it's both Monday and Wednesday. It's one or the other. There's no way it can be both Monday and Wednesday. Okay, so that would be an example of an exclusive disjunction. And then that brings us to our last connective or modifier. And this one's a little bit different because all of these bring like two things together. Okay? These previous modifiers. So this and that. If this, then that. This, if and only if that. This or that. This, X or that. Then the last one we got is the notion of the negation. And I'll say this because it doesn't have to have two pieces, but it is a modifier. So this is anytime we have the word not. Now, not in English is super sneaky as well because there's a bunch of prefixes and a couple of suffixes that indicate negation or meaning not as well. But we'll just say something like this. Here's how this comes into play. And what I like to use is I use the tilde, like you see above the N in jalapeno. Okay? You'll see it's on the top left of your keyboard, right underneath that escape button. So I like to use this for negation. Sometimes people will use like a minus sign. I don't like that because people get sneaky with the minus sign. Like I remember being when I was younger. Since we have these letters, what people will do is like, oh, here's A, but here's not A. Okay, is this A or not A here? And the student might go, yes. Well, to make that a little bit easier and more specific, I think using the tilde here makes it is a little bit more obvious. So that way, if I want to say like not A, it looks kind of like this. And sometimes we can call it the tilde, we can call it the not, we can call it some people will call it the squiggle. That's fine. So what does this mean? Well, here's A, not that. So if A were say something like, again, because I've been using this one a lot, let's say A stands for today is Wednesday. Okay, if I just had, I'll put that squiggle back there. If I just had A by itself, and I said A stands for today's Wednesday. Squiggle A then would mean today is not Wednesday. There's a couple other less enthusiastic ways I can say this that are grammatically correct, but they sound a little drier. So I can say it is not the case that today is Wednesday. It is false that today is Wednesday. So I'm not using the word not in there, but the concept of the negation is still embedded in what I'm saying. I suppose I could do this. Today is Wednesday, not right, or something like that. Today's Wednesday, psych. Okay, all those things would be fine, I suppose. So these are all the different kinds of modifiers that there are that we'll be using here in propositional logic. Now there are other kinds of modifiers as well. So if you open up your logic book, you'll also see sometimes there's things like you'll see the upside down A. So you'll see like this, and all that means is for all X. We will not be using these for this class, but I want you to, just in case you look it up, these things do exist. This means like this is a universal modifier. It basically means, for everything that is like this, the backwards E, this means there's something that's like this. Okay, there's some X such that it has this feature. Okay, there's also modal logic where you'll see things like squares and diamonds that indicate possibility and necessity, or rather necessity and possibility, respectively. But we won't be using those symbols. I just want you to know they exist in case you Google something and you run into all these symbols, just to at least have some idea that they're there and kind of what they are. But like I said, we won't be using those. So basically, when it comes to symbols, this is it. Like, so for formal logic, just like if you're taking a class on arithmetic, you need to know, your plus, your minus, your divide, multiply. Like for us, and I guess they're a negation as well. This is it. This is your whole repertoire of symbols. You know this. You know all the symbols that you need to know. Okay, for the most part, there's a couple of other symbols that I'll use, but that are just really kind of helps. They're not things that you need to know. These are all the ones that you need to know. Okay, so the next thing that I want to do is talk about the notion of these formalizations. These formal things over here need to be dyadic. So let's get into that. So here's the next thing to know about formal logic is all compound statements need to be dyadic. Now again, the negation is kind of a slight exception to this, at least so what I mean by that is this is technically simple. This is technically compound, even though there's only kind of one variable or letter involved here. But for all the others, for the arrow, for the dot, for the wedge, for the sniper sight, for for all of these, okay, the if then, and also a double arrow as well. Let me stick it up there. For all these, you can have, again, you can have if A then B. This would be A and B. This would be A or B. This would be A X or B. This is A if and only if B. Okay, and I'll put those up there again. So this isn't, what that arrow means is if then. What that dot means is and. What that wedge there means is or. And what that sniper sight means is like what I call X or. It's an exclusive or. Like pick one or the other, and then this one here, sometimes this is abbreviated in math, if and only if. If. The deal is with these are all what are called dyadic. So all formal statements of logic require them to be dyadic. Now here that's pretty easy. All that means by dyadic, by the way, dyadic is just a dyad is just a fancy word for two. So when you're saying dyadic, literally it means two-ish. That's all that it means. So here we have these dyads. So here, for example, the A, that's the left side. Left side, we got the right side. Boom. Two sides, it's a dyad. Okay, so all these are dyadic. That means they require a left side and a right. And we'll see we've got that here for both. We have a left side and right side. Here, this one's got a left side and a right side, left side and a right side, left side and a right side, left side and a right side. So these are all dyadic. They're good. And what do I mean by, how could it be otherwise? Well, look, if I put A arrow, and then there's nothing over here but emptiness, this is not dyadic. Okay, this is wrong. So you can't say if A then, and then nothing. Okay, so like if today's Wednesday, that's not a statement that you can use. And in fact, being dyadic is part of what we call being a well-formed formula. All right, or for short, WFF. So just like in math, in logic 2, we got to put things the right way. So basically, you can't have like neither can you have like an arrow over here just floating and maybe put a letter on top of it or something. No, you got to put it together correctly. So what I mean by correctly there is if it's any one of these arrows, dots, wedges, sniper sights, or double arrows, it's got to have something on the left side and the right side. It's got to have both. It's got to have a left and a right. That's what I mean by dyadic, and this makes it a well-formed formula. There's other aspects of it's just a well-formed formula. All that means, you've probably heard it in other kinds of math before, but all that means is just putting something in the most efficient way possible. So, like what I mean by that is, let's say, hey, write the number 5 up here. And I went, okay, 5 is 1 plus 1 plus 1 plus 1 plus 1 over 1. Is this 5? Yes, it is. Should you write it that way? No, don't do that. You're being obtuse. So if I say, hey, write 5, here you go. If you're going to get really spicy, I guess you could write a Roman numeral. So all three of these things here, these all are equal to each other. This means 5, this means 5, this means 5. But when we say like we want a well-formed formula, like there's a certain sense in which this is correct, but you're putting too much work into it. Okay? It's not as simple as it could be. So all that it means for something to be well-formed is it to be simple in this sense of you don't put it in an overly complex way, 1. And 2, that it's packaged the right way. The formula has the right kind of structure, like being dyadic. That's all that means.